All right, so here are the notes for 9.6, where if you are given a graph, you want to come up with the equation. So I've already gone through and kind of highlighted some of the details. And the nice thing is everything is in order as you would put it. I don't know why they have the brackets on this equation. It doesn't need them. So the first value is your new sinusoidal axis. And that is found by looking at what is the maximum, the highest value, what is the lowest value, and finding what is halfway between them. A lot of times you can just do it visually, but if you want to do it mathematically, you're basically taking an average of the high value plus the low value divided by 2. Then the second is your amplitude, A for amplitude, and that's always a positive, but you might sometimes put in a negative if what you are doing is a reflected graph. And so that is always that distance from whatever your new sinusoidal is to either the high or the low value. The period is how the distance it takes you to complete a cycle, but that is not what goes in the equation. What goes in the equation is 2 pi divided by that period. That gives you the B value. And then the fourth thing that you're going to put in here is where are you starting the cycle. So you have to think about, and this is what we are going to go through. If it's a positive cosine, where would you start? If it's a negative cosine, where would you start, etc. Or positive sign, negative sign. All right, so let's kind of get into this. What I always like to do is I kind of like to make a list of these right to start. So your vertical shift, which is your sinusoidal axis, then it's going to come your amplitude, then your period, which right away you then turn into what your B value would be, because that's going to give you your B value. And then we will have the phase shift, and what we want to do, kind of going above and beyond, we're going to figure out the phase shift for a positive cosine, a negative cosine, a positive sign, and a negative sign. Because if you can do all 4 of them, you're going to be totally set. All right, let's start this off. Okay, so I noticed that my high point is at 5, and my low point is going to be at -1. So what is halfway between 5 and -1 is going to be 2, because that's 4 divided by 2. So we know that 2 is going to be a sinusoidal axis. So this is going to be y equals 2, because that's always the equation of a line. Also, it's nice to kind of draw it on your graph. You can see that that's a line that goes halfway through the graph. And then we can also see that from 2 to 5, that's a distance of 3. And from 2 to a -1 is a distance of 3, so that verifies that our amplitude is 3. Now the period, that is, you just pick any point you want. I'm going to pick up here at this high point, and if I start to draw, notice as soon as I get to another high point, that represents 1 cycle. Okay, the distance it took me to go that cycle, that's going to be the period. Now, we only have a label here at pi over 8 and at 3 pi over 8. So that is a distance, 3 pi over 8 minus pi over 8 is a distance of 2 pi over 8, or pi over 4. So that means the next distance would also be a distance of pi over 4. Again, 45 degrees is the same as pi over 4. So to get from this high to this high, I have traveled twice that distance, which is 90 degrees, pi over 2. So my period is actually pi over 2, but that's not what goes in the equation. What goes in the equation is 2 pi divided by pi over 2. The pi's will cancel. So the B value that goes in the equation is going to be 4. What does that mean? That B value tells me I can complete 4 cycles within 2 pi. that's what that is actually meaning, which makes sense because look at how that is kind of shrunk, that graph. So I can do 4 of those within 2 pi. All right, so that's how we got the period by finding a point and finding out when that next repeat point is. That distance is your period. What goes in the equation is 2 pi divided by the period. That gave us the b value. Now we're going to start off on the phase shift because everything else is going to be the same. So I noticed that my positive cosine, remember a cosine starts high, ends high. So this one is the one that's already outlined. That one is going to start at pi over 8. Now, if I'm going to do a negative cosine, I'm going to choose a different highlighter. Well, let me do it this way. Negative cosine goes from a low point to a low point. So that would be to find a low point and then draw to the next low point. That would be one cycle of a negative cosine. And where did that start? That one started at 3 pi over 8. Then the next one we have is a positive sine. Sine starts on the sinusoidal. If it's a positive sign, it goes up first and then ends. So your sinusoidal runs right through the middle. So if I want to find, I'm going to start to get rid of some of this stuff. Is that not? I thought that was an eraser. Isn't that an eraser? Why is it not erasing? I don't know. Okay, well, that's fine. Don't erase on me. I don't care. All right, so I don't know why it's not doing it. But so I want to look at my sinusoidal axis, and I notice that right here, I start to then go up. So that tells me for a positive sign, I'm starting on the y-axis, so I don't really have anything to enter there. It's at 0. It's the x coordinate. Your phase shift is always the x coordinate where you start your graph. If I'm going to do a minus sign, then I want to find from the sinusoidal, notice at this point, and then I'm going down. So that's going to be where a negative sign would start. That blue point is halfway between pi over 8 and 3 pi over 8, which means it's at 2 pi over 8, and that reduces to pi over 4. Oh, I didn't give you the little graph. Okay, so that's what a negative sign would like. That's the main work. If you can do all of that, writing the equation is going to be easy peasy. So let me try and keep some same color coding. So for a positive cosine, I'm going to enter it kind of as it is in this list. So it starts off with your vertical shift plus your amplitude. This is a positive cosine. There's my b value. And my phase shift is going to be pi over 8. So that was the positive cosine. The negative cosine is 2. This now makes a negative. Everything else here is the same, except for where we start. We're going to start at 3 pi over 8. And if I'm doing the positive sign, it's going to be y equals 2 plus 3. Everything is the same, except for where you start. Whoops, I didn't need that. In this case, we're starting at 0, so I can just put it as x. And then the last one is our negative sign, so that's going to be 2 minus 3 sine 4, and then this one is going to start at pi over 4. Okay, now you're not going to have to do all 4 of these, but I don't know which one you're going to get. So if you can do all 4, it's like, yay, you're set. So the main thing is the vertical shift. That's the halfway between your high and your low. The amplitude is the difference from the sinusoidal to the high or the low, always positive. The period is the distance it takes to go from, say, high to high, at least the distance it takes you to complete one cycle. But what goes in the equation is 2 pi divided by the period. And then your phase shift is the x coordinate where you want to start your cycle. Okay? So we're going to do one more example on the next page. What we did in class is I had you guys try it, and then We went over it, so what I recommend is you pause the video, try that second example, and then see how you did. Okay, so let's see how you did. We're going to have a vertical shift, we're going to have an amplitude, we're going to have a period, which has to give us a B value, and then we're going to have a phase shift, and we're going to do all four. So the positive cosine, the negative cosine, the positive sine, and the negative sine. All right. So my vertical shift, I notice my high is at 1. My low is going to be at -3. That is a distance. Well, I'll do it algebraically. You can usually kind of just eyeball it. I mean, hopefully you can see that -1 is going to be the value that goes right through the middle. But otherwise, you do -3 plus 1 divided by 2, and that'll give you a -1. So this will be y equals -1. My amplitude is then that distance from the sinusoidal to a high or a low. Should be the same on both. It's 2. My period, so let's see. Again, they're only showing us half of a period from a high to a low. If that's 1/2 and this is 3/2, and then this is 5/2. So if we're trying to figure out this distance, 5/2 minus 1/2 is 4/2, which equals 2. So my period is 2, but the B value is 2 pi divided by the period. So that simplifies out to pi. Now we want to do our phase shift for each of our different functions. Remember, there's a positive cosine, a negative cosine, a positive sine, and a negative sine. They kind of look like that. So the positive cosine starts high, ends high, and so this will be for our positive cosine. I'll kind of label the graph where we're using. So that one is going to start at 1/2. The negative cosine is going to start at a low point, so this will be where we start. That's going to be the x value. And then for sine, positive sine, I'm going to start a positive sine again on the y-axis, so that won't have a phase shift. And if it's a negative sine, I want to also start on the sinusoidal, and then that one goes down. So notice that's going to be at 1, because that's halfway between 1/2 and 3/2. All right, so this will start at 1. Once you have that list filled out, the rest of it is just writing out the equations. So we are going to have the y equals -1 plus the amplitude. This is going to be the positive cosine pi x minus 1/2. Then we get to the negative cosine. So -1 minus 2 cosine pi, that one starts at 3/2. Then for the positive sine, that's going to be -1 plus 2. It's kind of nice. Everything's basically the same because they're just translations, horizontal translations of each other. Whoops, silly me. See, I can't talk and write at the same time. This should be a sine pi x. And then the last one is our negative sine, -1 minus 2 sine pi. That's starting at 1. And that would be it. All right. So if that's all you had, I am going to add one last example here. Someone requested just going through how to graph from scratch one of these equations. So I'm going to just write down one equation and go through it. So I'm going to make something up. I hope this works okay. Y equals, let's make it -2 plus 4, and I'm going to do a sine. I should probably do a reflected, but I didn't. Let me make this be, I don't want to make it too easy, but I don't want to make it really hard either. And then x plus 1. All right, so I'm going to draw myself an axis and go through the process that I would like you to do. Now, I recommend, if it doesn't ask you to do this, we always do this in pre-calc anyway, we write this down. I always have you write it down. And I always add, even though it won't be on your list, but I'll put that there. Okay, so my vertical shift is always this first value. That's your sinusoidal axis, so y equals a -2. Amplitude is going to be that next value, and then the period is 2 pi divided by the b value, and that simplifies out to 4. So that's the distance it takes me to complete a cycle. This one is going to start at a -1 because you always set this equal to 0. So x is going to start at a -1. And if I'm going to go a distance of 4, it means I'm going to end at 3. So I add these two to get my start. This is where I start my graph, the x value. This is where I end. And then these two tell me how to set up my y-axis. All right, so my vertical shift is at -2. So here is a -2, and I add my amplitude, add and subtract. So -2 plus 4 is going to take me up to 2. -2 minus 4 is going to take me down to a -6. So I do this, you don't have to. I just like to give myself a little dotted line so I can know where I am in all this empty space. Okay, so I have my high, my low, and my sinusoidal. My graph is going to bounce around in those borders. That takes care of all of that. Now for the x-axis. The x-axis comes from where I'm going to start and where I'm going to end. So I'm starting at a -1, and I'm just going to, well, I don't want to put in values we don't need, so I'll wait on that. Okay, so I'm going to start at a -1, and I know that I'm going to end at 3. So that's my start, that's my end. However, I need to show all the sort of midway points. So what's halfway between 3 and a -1? Turns out it's going to be at 1, because each of those is a distance of 2. How did I get that? You can take an average. 3 plus -1 is 2, divided by 2 is 1. What's halfway between 1 and -1 is 0. That was easy. And halfway between 1 and 3 is 2. So notice I have 5 points where I start, where I end, halfway, and then like a 1/4 and a 3/4 point. There should always be 5 markings. Now, if you've got that down, the rest is just plotting your points. Since this is a sine graph, it starts on the sinusoidal, so I'm starting on my sinusoidal. Then it goes high, because it's not reflected. Then it goes sinusoidal. Then it goes low. Then it goes sinusoidal. And from there, I just smoothly connect my dots. And that would be the graph. Now, I hope this isn't going to be too confusing, but what if I had given you -2 minus 4 cosine pi over 2 x plus 1? So everything is the same, but we're going to do a reflected cosine. So all the values are basically the same. Well, cosine usually starts high, but reflected, it would start low. So it would be down here, and everything else will be the same. Then it goes to the sinusoidal, then it goes to the high, then it goes to the sinusoidal, and then it also ends low because it's reflected, and we connect those dots. Notice how you can even see when you graph them right next to each other, on top of each other, they really are just translations, horizontal translations of each other. The shape stays the same. All right, I hope that helped.